So Raichoo came here to Lambda World trying to convince all developers, all Scala and all functional programming developers, trying them to promise, to convince them to work hard, to keep things lazy. Is Haskell a language to keep things lazy, really?
Yeah, I have to admit I'm kind of lazy. I don't like writing stuff twice or like 3 times. I just want to solve a problem once and then be done with it. And Haskell is a very good language to do that. So at my work, whenever we're doing a project, I find a lot of problems that I can just put into a library and then the problem is solved. I don't have to do this anymore. And I haven't had this kind of experience with any other language before. So yeah, it's a lazy language.
And what is it, this non-evaluation strategy?
So basically, Haskell, or to be precise, GHC Haskell, is the only language that I know that has this kind of lazy evaluation. That means so it happens. So it evaluates something when it really needs to. So this is kind of like an informal way to describe it, but there's when you really need a value, then the computations happen. So imagine you have a program that might have a very, very expensive argument, but you don't really need it. So in some languages, you compute this you have to compute this even though you don't need it. And in Haskell, that's not the case or in GHC Haskell, it just evaluates the things when it really needs to. And I think this is pretty handy. You can do a lot of cool stuff with that.
So could you share with us some of these techniques that the compiler performs?
Yeah, so some of the stuff that GHC basically does is called strictness analysis. So with laziness, there's the problem that you can allocate a lot of memory, and that can be kind of bad because this is what we call a space leak. So a lot of memory gets allocated and it doesn't get freed when you expect it. So there is something that's called strictness analysis that can basically figure out where and when we want strictness, because it might be the thing that we want. And so if you turn the optimizations on, GHC can figure out where these spaces are. And it can also generate worker functions that just consume machine input, like machine integers, to work with that. So they're not basically boxed, and you have to do this all this unboxing, which takes a lot of time and performance. So it can do a lot of tricky optimizations there. So yeah.
Would you repeat next year here?
Yeah, of course. If you invite me, I'll be here. It's a great conference. I love Lambda World. Been here last year, and this year is great as well. So.
Okay, so looking forward to. Have a nice time here.
Thank you very much.
Thank you.
Bye.